In order to prove parallelograms in coordinate geometry, we need to use formulas. If we want to show that FOUR is a rectangle, start by plotting these 4 points. To prove that FOUR is a rectangle, we need to prove certain things. We can prove that it's a prove that it's a rectangle by looking at its sides and angles. A rectangle has opposite sides that are parallel. To prove in coordinate geometry that our opposite sides are parallel, we need to use the slope formula and show that our opposite sides have equal slopes. Now, step 1 only proves that this FOUR is a parallelogram. To make it a rectangle, we need our consecutive sides to be perpendicular. We need all of these angles to be right angles. To show that our consecutive sides are perpendicular, we're going to use the slope formula again and show that our consecutive sides have opposite reciprocal slopes. Now, step 1 proves that we have a parallelogram. Step 2 proves that we either have a rectangle or a square. To narrow it down, to prove that we have a rectangle and not a square, our opposite sides have to be congruent, but our consecutive sides have to not be congruent. To prove that our opposite sides are congruent and our consecutive sides are not congruent, we're going to use the distance formula to find the length of all the sides. A second way to prove that we have a rectangle is to look at the diagonals. The diagonals of a rectangle will have certain properties. The diagonals of a rectangle have to bisect each other. To prove that these diagonals bisect each other, I'm going to find the midpoint of each diagonal and show that the midpoints are the same. To find the midpoints, I'm going to use the midpoint formula. Now, all parallelograms have diagonals that bisect each other. I want to specifically say that this is a rectangle. So in addition to having diagonals that bisect each other, the diagonals have to be congruent. To prove that our diagonals are congruent, we need to find the length of each diagonal. To find the length in coordinate geometry, use the distance formula. The first statement here proves that we have a parallelogram. The second one narrows it down to either a square or a rectangle. The last one will prove that we have a rectangle. The difference between the diagonals in a square and a rectangle is, in a rectangle, our diagonals are not perpendicular, and in a square, the diagonals are perpendicular. So our diagonals have to not be perpendicular. We have to show that our slopes are not opposite reciprocals. Both of these game plans prove that I have a rectangle and only a rectangle. Either game plan works. I just need to decide which one I want to use. I'm going to decide to use the diagonal game plan. I can pick either one. The thing I don't want to do is jump back and forth. If I start with the diagonals, I want to use diagonals throughout. If I start with sides and angles, I want to use sides and angles throughout. I don't want to pick this one, and then this one, and then this one. I want to stick to a game plan. So I'm going to start by proving that my diagonals bisect each other. I need to find the midpoints of both diagonals. I'm going to start with segment UF and find the midpoint of UF. To find the midpoint, I need to find the average of my x values and the average of my y values. So I'm going to take x2 plus x1 divided by 2 and y2 plus y1 and divide it by 2. I'm going to look at my ordered pairs for u and f and find out my x2 and my x1 and my y2 and my y1. Now I need to do the math. 7 plus negative 7 gives me 0. 0 plus 2 gives me 2. 0 divided by 2 is 0, and 2 divided by 2 is 1. I can plot the point 0, 1. 0, 1 is right here. Now I need to find the midpoint of my other diagonal. My other diagonal is OR, and I'm going to use the same midpoint formula, average my x's, average my y's. And I'm going to look at the ordered pairs for O and R and find x2 and x1 and y2 and y1. And then do that math. Negative 5 plus 5 is 0. Negative 4 plus 6 is 2. Simplify my fractions. 0 divided by 2 is 0. 2 divided by 2 is 1. So this shows that my midpoints are the same. Which means that my diagonals have to bisect each other. I can check task 1 off my game plan. Let's go on to task 2. I need to prove that my diagonals are congruent. To prove that my diagonals are congruent, I'm going to find the measure of each diagonal. To find the measure of each diagonal, I'm going to use the distance formula. The distance formula says subtract my x's and square that, subtract my y's and square that. So I'm going to look at my ordered pairs for u and f and find out that x2 is negative 7 and x1 is 7 and y2 is 0 and y1 is 2. Now I need to do this math. Negative 7 minus 7 is negative 14. 0 minus 2 is negative 2. Keep going. Negative 14 squared. Notice that negative 14 is in parentheses, so when I use my calculator, I need to put negative 14 in parentheses. A negative number squared gives me a positive answer. Same with negative 2. Negative 2 squared is positive 4. It's negative 2 times negative 2. If you're getting a negative number here, double check your math. Both of these numbers should be positive. So the measure of my first diagonal is going to be the square root of 200. And I can approximate the square root of 200 using my calculator. The square root of 200 is approximately 14.14. Now I need to find the measure of OR. To find the measure of OR, I'm going to use the distance formula. Subtract my x's and square that, plus subtract my y's and square that. So I look at the ordered pairs for O and R, and I write down my x2 and my x1, and my y2 and my y1. And then I do that math. Negative 5 minus 5 is negative 10. Negative 6 minus 6 is also negative 10. Now I need to keep going. Negative 10 squared. A negative squared is going to be a positive 100, and negative 10 squared is also positive 100. So the measure of OR is going to be the square root of 100 plus 100, which is 200. And the square root of 200 is approximately 14.14 big. Notice that I got the same answer twice. That's what I want to see. But I got that number by using different numbers. So what does that tell me? Well, the measure of UF is equal to the measure of OR, so my diagonals are congruent. I just showed step 2. Now I need to go to step 3. I need to prove that my diagonals are not perpendicular. To prove that my diagonals are not perpendicular, I'm going to find the slope of each diagonal. To find the slope of each diagonal, I'm going to subtract my y's and divide that by subtracting my x's. And I look at my u and my f, and I find the ordered pairs, and I take y2 minus y1 over x2 minus x1. Now I need to do this math. 0 minus 2 is negative 2. And 7 minus negative 7 is positive 14. Now I need to simplify this. A negative divided by a positive is a negative, and 2 divided by 14 is 1/7. And I can check my answer by looking at my picture. The slope of UF is negative. It falls from left to right. And if I count, I have 1 over 1, 2, 3, 4, 5, 6, 7. Down 1, to the right, 7. So my slope is negative 1/7. Now I need to find the slope. I should have written slope here. I need to find the slope of OR. The slope formula is y2 minus y1 over x2 minus x1. So I need to look at my ordered pairs and pick out y2 and y1. And x2 and x1. Negative 4 minus 6 is negative 10. Negative 5 minus 5 is negative 10. A negative divided by a negative is a positive. And 10 divided by 10 is 1. And I can check that answer by looking at my graph. The slope of OR is positive. It rises from left to right. And if I go up 1 over 1, up 1 over 1, that is the slope of my diagonal. So if I look at these two slopes, they're opposite. One's negative, one's positive, but they are not reciprocals of each other. So the slopes are not opposite reciprocals. So that means that my diagonals are not perpendicular. So I've showed all three things to prove that FOUR is a rectangle.